In this video, you're going to examine the properties and uses of hydrogen. Hydrogen is a colourless, odourless gas at room temperature and is the first element in the periodic table. As an element, it is a diatomic gas with a molecular weight of 2, making it the least dense of all gases. This low density made it a natural choice for one of its first practical uses, filling airships, but this future ended when Hindenburg airship caught fire on the 6th of May 1937. Hydrogen is easily the most abundant element in the universe. It is found in the Sun and most other stars, and the giant planets like Jupiter are composed mostly of hydrogen. On Earth it is found in water, fossil fuels and living things, but very little as the element on its own. In the chemical industry it is used to make ammonia for agricultural fertilizer, the Haber process, and to make cyclohexane and methanol, which are needed to make plastics and pharmaceuticals. It is also used to remove sulfur from fuels during the oil refining process, when it forms the bad egg-smelling gas hydrogen sulfide, H2S. Large quantities of hydrogen are used to hydrogenate vegetable oils to form fats, for example, to make margarine. The H in the pH scale denotes hydrogen. It represents the concentration of hydrogen ions in water. When the pH is lower than 7, the solution is acidic, and it is the hydrogen, or more strictly the hydroxonium ion, that makes the acids reactive. Thus, metals above hydrogen in the reactivity series normally react with acids to form hydrogen, like zinc with hydrochloric acid. However, if the metals form an insoluble salt, little reaction will occur, for example lead in sulfuric or hydrochloric acids. Aluminium metal, although well above hydrogen, is covered with a tight layer of oxide which protects it from acid corrosion. Unreactive metals below hydrogen do not displace hydrogen in acids. The most reactive metals will react with water itself, sodium for example. You can test for hydrogen by exposing it to a flame. It ignites with a squeaky pop, and you can see condensation in the tube as water is formed. Although hydrogen is an essential element for life, it doesn't play a particularly active role. It remains bonded to carbon and oxygen atoms, whilst the chemistry of life takes place at the more active sites involving, for example, oxygen, nitrogen and phosphorus. When fossil fuels form, these more reactive elements are removed during the decay process, leaving the hydrocarbon skeleton behind as crude oil and natural gas. If we compare coal, oil and natural gas and hydrogen as fuels, you can see that when they combine with oxygen, coal and crude oil produce the most carbon dioxide. So using natural gas in place of oil and coal does help reduce carbon dioxide emissions. Hydrogen, which only forms water when it burns, could be the clean fuel for the future. But the hydrogen must be generated from water using replenishable energy. Hydrogen has 3 isotopes. Normal hydrogen with 1 proton in the nucleus, the very rare deuterium, or heavy hydrogen, with a proton and 1 neutron, with twice the atomic weight of normal hydrogen, and the artificially made radioactive tritium with 3 neutrons. These isotopes are being used by scientists trying to copy the fusion reaction of hydrogen in the stars to get clean nuclear energy. Currently, all nuclear power stations use fission reactions where very large atoms like uranium break apart, producing lots of radioactive waste. So there you have it, hydrogen, a fuel for the future, and the element that helps carbon form the backbone of life itself.